another oblique triangle that we can solve. And notice I have an obtuse triangle, doesn't matter. But in this one, I have an angle, side, angle is what is known. Again, we need to know have two angles and a side, and the layout of this particular one is just happens to be in the form angle, side, angle, or ASA form of the triangle. So it's up to you. You can start wherever you want to start. Well, probably should start with trying to find out the third angle first. That would be fairly straightforward. Again, interior angles add up to 180. So 50 plus 33.5 is 83.5. Subtract that from 180 and I get 96.5 degrees for that third angle. And then from there, I want to find what C and B are. Sorry, that's an A over there, folks. I want to find what C and A are, and I know what the B ratio is. I know what angle B and its sine and its length is. So let's choose one where it has for A. So A over the sine of A, which is 50, equals a ratio that we already know, where I know B, which is 76, over its sine of its opposite angle, which is 96.5. And then I can solve that for A, and that equals 76 times the sine of 50, all divided by the sine of 96.5. And let's crank that out, see what we get here. 76 times sine of 50, close parentheses, divide by the sine of 96.5. Enter. Tells me I get 58.59. Let's round up to 58.6. So that was for A. This side is 58.6 units, whatever this particular problem's measured in. All right, now I need to find the length of side C. I can choose any ratio that I want. Since I know both A's and B's now, I can use either one. So let's take side C over its sine, which is 33.5, sine of 33.5 equals a ratio that we already know. I'm going to use the same one since it's already up there. Solve that for C. C equals 76 times the sine of 33.5 divided by the sine of 96.5. Black box work, because this is not an angle that I already know. It's not one of the 16 special ones. So 76 times sine 33.5 divided by sine 96.5. And if I typed everything in right with my fingers, I get 42.2. units. And that's not all that surprising. I'm expecting this side to be the shortest length because it's opposite the shortest angle, and likewise around the triangle. So there, by using the law of sines in a triangle, an oblique triangle where I know an angle, a side, and an angle, I was able to discover the remaining unknowns.